Happy day, everybody. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Today, we are taking a topic that is related to both mathematics and physics, and that topic is vector. So today, we are taking what position vector actually mean and what displacement vector actually means. So we are taking a topic that says the position and displacement of vectors in Euclidean space. That is a real number space that may be 2D or 3D system. So now, before we go further, I want to remind us what vector is all about. We know that a vector is a quantity that has both magnitude and direction. Like for instance, consider this particular vector. Call it vector A, originating from point A and terminating at a point B. This originating point is called the tail or the vector. This terminating point is called the head or the vector. Now, where the arrow face is called the sense or the vector, and the angle the vector makes with an arbitrary horizontal axis, the angle describe the direction of this particular vector. Another thing I want us to take note of is this. We have a very small vector that is called a unit vector. This unit vector is in the direction of the bigger vector AB. So I can denote this unit vector with this particular symbol A caret on top. Now, to be able to equate this big vector AB, which is this A, to this unit vector, I call it unit vector. So I call it unit vector. So to equate these two vectors together, we have vector A is equal to the size or the magnitude. That means the length of this line. That particular length is length AB. So but I can rewrite it as ordinary A, then times this unit vector. Or I can write this ordinary A as the magnitude of vector AB. A with this arrow going towards B, then times the unit vector. If you are asked to find unit vector, you divide both sides by the magnitude or the size of this line. So we are going to have the vector A divided by the magnitude of that vector A will give us the unit vector. So let us realize what a vector is all about. Now, we want to talk about the difference between what is called, number one, position vector, and number two, displacement vector. Displacement vector. Now, the difference is this. If we have a fixed point, this particular fixed point, call it fixed point O, and you tie a vector, this is a fixed point. That means this particular point O does not move at all. And you have a vector connecting O to a point, let's say A. This particular vector that we have here, whose tail is tied to a fixed point, is called position vector. Position vector. Why do we say position? It's telling us about the position of point A. That means if this vector make an angle theta in this direction, we can be able to look at this length of this line and with this particular direction to describe the location of point A. So a position vector can be called fixed vector. Fixed vector. Fixed in the sense that this vector cannot be moved to anywhere from where it is. Now, if for instance now, I have another point from, let's say A moved down to point, this particular point A moved down to point B. Because A moved from this point A to point B, this particular vector AB, this vector AB moving in this direction that I have here is called displacement vector. Displacement. vector. It's called the displacement vector. Why do we say displacement vector? Displacement vector in the sense that the point A is being displaced to a new position, point B. Now, this particular point B too can have its own position vector. So, in a nutshell, let me have line AB here. This particular vector AB. Let me have it here. Now, if I tie a vector to a fixed point O so that it can describe this point A, and I tie another vector to fixed point O again so that it will describe the location of a point B. Now, this particular vector that I have here that is tied to this particular fixed point is called the position vector of point A. This other vector that I tie to this fixed point is called position vector of point B. So position vector of point A, if I replace it with this letter, and position vector of point B, if I replace it with this letter, because point A moved down to point B, this place is called displacement vector. I want to find expression for this displacement vector AB. Displacement vector AB in terms of the position vector of fixed point A and the position vector of fixed point B. Now, look at what I want to do. If I want to move from A to B, I may just move along this line connecting A and B. Another way to reach point B, starting from point A, is to move from here like this and go like this and get to point B. Now, as I'm moving, I have to be looking at the sense. I mean, where the arrow is pointing to, the sense. Now, from point A to B, that is point A, B. That means moving from A to B can also be taken as moving against the direction of this arrow. The moment you are moving against the direction of the arrow, you put negative. That is minus vector A. Then you move along this other vector that we have here. That is a vector B. That is plus B. So we have vector AB is equal to B minus vector A. So that means displacement vector AB, displacement vector is this sum of this position vector of point B minus position vector of point A. So that's how we can have the expression. Now, let me say the coordinates of point B. I take it as x2, y2, and z2. And then the position vector for point A, let me take it as x1, y1, and z1. If I put this expression here, this one and this one, in this expression I have here, the position vector AB can be written as x2, y2, z2 minus that of the position vector of A, x1, y1, and z1. So we assume that this particular point line AB is located in a three-dimensional space, so that the coordinates of each of these points will be described by the the components along the x-axis, along the y-axis, along the z-axis. The same thing is applicable to point B. The coordinate of point B is the vector of point B is decomposed into the value along the x, y, and z. So this expression I have here is called the Coulomb the column vector form. Column vector form. I can write this one in rectangular form by writing this as a x2i plus yzi plus z2k. Then I will say minus. For this other one, I will say minus x1 in the direction of I plus y1 in the direction of j plus z1 in the direction of k. So that is the displacement, the expression for displacement vector AB. So I believe that you have taken note of the difference between position vector and displacement vector. Now let's do an exercise relating to what we just did now. Let's say the question says a line passes through point A. So I have it as a 0, 2, 4 and point B described as 3, -1, 0. The question says determine the displacement vector connecting the 2 points. So if I were to do this question, I will write solution. This A, which is a 0, 2, 4, I'll take it as point x1, y1, and z1. And point B, I will take it, the point B, which is a 0, -1, 0. I will take it as a x2, y2, and z2. Now, the formula for displacement vector that I just proved now is R is equal to vector B minus vector A, where vector B is the position vector of point B and vector A is the position vector of point A. So that is B1, B2, B3 minus A1, A2, A3. This B1, B2, B3 that I have written here is the same thing as X2, X1, sorry, this is supposed to be X1, X2, sorry. So it will be X2, Y2, Z2, then minus A1, A2, A3 is the same thing as X1, Y1, and Z1. So we can now substitute this value inside this expression here. So that means the displacement vector, which is AB, can be taken as 3, -1, 0. Take away 0, 2, 4. So we now write the final answer as 3 minus 0, that is 3, -1 minus 2, that's -3. 0 minus 4 gives us -4. So the displacement vector passing through points A and B is given as the column vector 3, -3 or -4, which can be written as in rectangular form as 3i minus 3j minus 4k. So that is the value for the displacement vector passing through point A and B. I believe that you've learned one or two things pertaining to this topic on vector. Please do not forget to share, like, subscribe. Click on the notification button to have more of my video. Thank you so much. Have a nice day. Bye.